All right, so we're back here, and my face is not here. I'm sorry about that. But let's do some examples about calculating density. So I encourage you to pause whenever you feel like you kind of got the hang of this, so you can try some of these out for yourself. I don't want you guys to have me do all these problems for you, because you're going to have to do some on your own for classwork today. So let's calculate density. Let's look at this problem. A feather has the following properties: 0.01 grams, 4 milliliters. So that little g there is for grams. That is a mass. 4 milliliters, that's the unit of volume. So what is the feather's density? And then we have the equation: density equals mass divided by volume. Okay, so let's work through this. Whenever you do a problem, I always encourage you to hang on. Something's not working here. Okay. Huh. Okay. Strange. I always encourage you to rewrite the formula. So density equals mass divided by volume. I just apologize for my sloppy handwriting. Usually you can do this with my fingers, but my computer's not agreeing with me right now. Anyway, density equals mass divided by volume. The next thing I encourage you to do is just create an inventory of everything you know so far. So here's my inventory. Let me do this in a different color. So my inventory right now, I know my mass is equal to 0.01 grams. And my volume is equal to 4 milliliters. Okay, so that's what I know so far. And now I just ask, well, can I solve for density? Density equals mass divided by volume? Well, yeah, I can. I have the mass and I have the volume. So then I just go back up here and I do the problem. So 0.01 grams divided by 4, that's a 4 milliliters. Okay? So, well, now what? Well, I'm not going to do long division. I'm not expecting anybody in this class to do long division. I'm just going to get out my handy-dandy calculator. So here, I'll even pull it up for you guys. Calculator. Oh, yes, we have a calculator. So I'm going to say 0.01 grams divided by 4 milliliters. I get 0.0025. Sorry, guys, let me get that answer up again. Was it 0.0025? Okay. 0.0025. Oh my goodness. There we go. So you might think, okay, we're done. No, we're not. So you notice that there is something in the equation I didn't put in the calculator. That's the grams per milliliter. Well, I keep that as a part of my answer. Those are my units. If I just have the number 0.025 all by itself, that doesn't describe anything. It's not telling me, well, 0.0025 what? Pumpkins, bananas, cars, dollars? Well, this is density. So 0.0025 grams per milliliter. So this is a fairly small density. We're talking about feather here, so we should have gotten something small. Okay, so there's our first answer right there. Now let's go to the next question. Okay, let's do the next problem. Oh, I didn't think you'd be able to see my face in there. Okay. Okay. Oops. Okay. Calculating density. We're still using grams per milliliter. A piece of iron takes 0.635 milliliters of space and has a mass of 5.0 grams. Okay, so pause the video. I encourage you to pause the video and try to do this on your own. All right, so I hope you pause the video and try this on your own. I rewrote the equation because I want you guys to get used to just rewriting the equation. I know it's redundant because we're doing the same thing over and over, but soon you're going to have more than one equation. You're going to have more than 2 or 3 or maybe even 4 equations on any given quiz. And I want you guys to know what equation you have to use to get to the goal. So the goal here is density. So we know density equals mass divided by volume. My mass... Well, again, we're doing some inventory now. My mass I have a mass of 5 grams. So let's just go ahead and write that in there. Mass of, oh my gosh, 5 grams, 5.0 grams. Why am I putting the 0.0 there? We'll get to that later. And a volume of, remember what it says takes up so much of space? That's a volume word there. 0.635. Oh my goodness. Oh my goodness. I'm gonna have to fix this, guys. That's a pretty good 5, actually. Wow, I'm proud of myself. 0.635 milliliters. I'm sorry this looks like kindergarten wrote it. I am gonna get my computer fixed, I promise. Okay. Do we have everything we need to solve for volume? Or sorry, density? Density equals mass divided by volume? Well, yes, I do. I even have all the equations lined up, all the terms lined up. So I can go and plug this into my equation. 5.0 grams. I know it's a pain to keep those units in there, especially when you're using this little mouse thing I'm using, but I encourage you guys to keep the units in there. Helps keep everything straight. Divided by 0.635 milliliters. Okay. And again, we're not going to do long division. We're going to use a calculator. We're done with Math Lab now. So 5 divided by 0.635. Okay, so here's a big number. How many digits do I keep? Well, I'm only going to keep the first 2. Why am I doing that? I'll tell you later. But so 7.87. So I'm going to say that equals 7.9. So again, sorry guys. I'm going to go down here. So we have 7.9 grams. Oh my gosh, that's a horrible G. Can't live with that G. Grams per milliliter. Okay? So remember, our last answer was 0.0025. That was a very small number. This is a little bit bigger. Remember, we're talking about iron. Iron has a much higher density because you can pack a lot more iron in a lot smaller space. So you should expect a higher density than the feathers for iron, right? It's harder to pick up a chunk of iron than it is to pick up a chunk of feathers. Okay, so last problem. And again, if you're having trouble viewing this video, I encourage you to go to the help video section of Google Classroom and look up the basic YouTube controls. It just kind of tells you some hints on how to fast forward, how to slow down videos, and lots of stuff like that. So, last one. We're going to calculate the average mass of a human. average density of a human. The average human has a mass of 62 kilograms and a volume of 0.614 cubic meters. What is the average density of the average? What is the density of the average human? So again, I'm asking you guys to maybe pause and try on your own. I think I'm getting the hang of this, right? some time for me to fix this thing. So again, I hope you pause and try it for yourself. And I'm going to go through it. Density equals mass divided by volume. So mass of 62 kilograms. So I can go ahead and write that in my inventory. 62 kilograms. Notice that's not grams this time. It's kilograms. The kilogram is 1,000 grams. So an average mass of a human is 62,000 grams or 62,000 paper clips. A volume of 0.0614 cubic meters. Now, that might seem like a small number. You're like, that's how much space a person takes up? That can't be right. Well, remember, the units are different here. This is a cubic meter, not a milliliter. So it's a little bit different. Okay, so we have all the information we need to calculate density now. So 60, okay, excuse my writing, guys. Okay, magic fingers, don't fail me now. Okay. 62 kilograms, I'm so sorry, guys, divided by that bigger number, or smaller number, 0.0614 cubic meters. Okay? I'm going to write the answer really big because these units are too small to write. Okay, so again, handy dandy calculator, 62 divided by 0.061614 cubic meters. Look at something like 1,009 point whatever. Okay, so I'm going to round that up to 1,010. Okay. And actually, I can just call it 1,000, really. Why am I rounding up like that? Why don't I keep all the digits? Again, stay tuned for that. So the density of an average human is about 1,000 kilograms per cubic meter. So, well, that's really big. That's bigger than iron. Well, not necessarily. Remember, these units are different. I just want to test your ability to use different units. So the number is going to be a little different. But if you got around 1,000, I think you did that right. Let me just check my math real quick. I remember getting a different answer last time. I could be wrong. Divide by 0.0614. Is that the right number? Yep. All right. One more bonus fact. This is for my online class right now, and my in-person class, I was going to have you guys calculate the density of water. The reason is because I wanted you guys to see something. The entire metric system is based off of this one fact, that the density of water, I'll just say D water, whatever. The density of water is equal to grams per milliliter. Can you guys guess? It's 1 gram per milliliter. The entire metric system is based off of that one simple fact. So that's how we adjust our length, adjust how our mass, is that we want the density of water to be a simple number. So every milliliter of water that you pick up is exactly 1 gram. And we've adjusted the metric system to reflect that fact. And if you ask, well, why do you do that? Well, because water is everywhere. Water is over 70% of the Earth's surface. Now, salt water is a little bit different, but pure distilled water density is 1 gram per milliliter. And that just helps us adjust and keep everything the same. All right, so I hope this helped. What I want you guys to do is I want you to look at all 3 readings today. The first reading you have for today is just going through those basic physical properties. The second video talks a little bit more specifically about mass, volume, and density. And the last thing you guys are going to do is you're going to actually practice using some of this math in your first CK12 practice session. So look out for that assignment in Google Classroom. It should be on today's agenda as well. If you have any questions, I encourage you to comment on this video or leave a comment in Google Classroom. Email me. Lots of ways to get a hold of me. Never be afraid to reach out, and I'll see you in class.